All right, if you're back for more, I'm surprised because this is a very painful, or the last section was very painful. So thanks for sticking through it. But now I think we're on to bigger and better things, more interesting, a lot less graphing. This section should have no graphing, which should make you happy. Makes me happy. We're almost getting to the end of this chapter. This chapter has a lot thrown in. Just kind of a bunch of stuff that we're supposed to know before we start doing the really important things that we're going to see in chapters 3 and on. So the last section kind of focused on graphs and how to obtain a new graph from an old graph without starting from scratch and plotting points, But this section, now we're taking two different functions and we're going to combine them in different ways. And there are applications in real life, but I think we'll see those later. So this section 2.6 is combinations of functions, semicolon composite functions. So we'll see what those are. You might have seen those if you took second year algebra or second semester algebra before. Probably. So this should probably be review. A little bit of it might be new. I don't know, but the intro to this section is a little bit of a bummer. Check this out. We're born, we die. Wonderful. Thanks, guys. Now I got to contemplate my own mortality while I'm trying to do math. I was just trying to have a good time and do some math, you know what I mean? Jeez. Well, anyway, they say that this graph below quantifies these statements, we're born, we die, by showing the number of births and deaths in the United States from the year 2000 through 2011. So one thing I kind of took notice of, which I don't know if you give a crap, but 2011, the most recent year they show, the number of births is down, So, and I think I've read that recently that the number of births is going down a lot. I think someone was saying that we're almost to the point where we're not having enough kids to replenish the country, that kind of thing. Like we have to rely on immigration a lot more because pretty soon there won't be enough people left to even run the country because we're all dying off and not having babies. So that's interesting, huh? It's like it doesn't not what you would think would be happening, I guess. I don't know why. You seem like you see babies everywhere, right? But anyway, that's neither here nor there. But it looks like the deaths are pretty steady, huh? Look at that. Ooh, the deaths are up in the most recent year. Ew. What's with that? Okay. Well, we can think about that later, huh? Right now, you guys don't pay me to to talk about graphs and deaths and all that. But okay, in this section, we look at this data from the perspective of functions. By considering the yearly change in the U.S. population, you'll see that functions can be subtracted using procedures that will remind you of combining algebraic expressions. So yeah, there are times in real life where one function represents something in real life and another function represents something else in real life, and it actually makes sense in that situation to add or subtract. So the one that I think of, for example, is in business. What is it? What do you have? You have cost. Like if you start a small business or whatever, and cost is how much it costs you to create an item or a big supply of items, and then there's revenue, and what's the other one? Don't tell me. And profit. That's what it is. So I guess the revenue, that's how much you make from the items that you built or you had built in a factory, whatever. But that's not really how much money you're making because it costs you a lot to make those objects. So if you want to know how much money you're making, your profit, it's the revenue, which is how much you made from the items, minus the cost. That would be how much you're actually profiting. So if you had like a function that represented the cost and a function that represented your revenue, you would subtract them to find the profit, and that would be a new function. So that's just an example. I don't know if you give a crap. You might want to know why we study these things. Maybe you don't really care. Either way. So okay, but the first objective, before we get there, that's a little further down in this section. First thing we want to do is how to find the domain of a function. So this you might have seen, like I said, if you took second semester or second year algebra, how to find the domain. But that's something that even if you've seen it before, I almost guarantee that you've forgotten. If you haven't forgotten, wow, good job. You have an amazing memory. But this is a good step-by-step procedure. If you see a function, you just follow these 3 steps and you can find the domain. Okay, so just as an overview, what you're really looking for is, does the function that you're given have some kind of even root, which means a square root or a fourth root or a sixth root. If I see a cube root or a fifth root, I'm not worried about it. I'm only worried about even roots, square roots, fourth roots, on and on. So you're looking for a root, an even root, or a function that contains some kind of denominator with x. So that's where you run into problems because, if you've seen before, if you see a fraction with the x in the denominator, you're worried about that denominator being 0, because you can't have a 0 denominator. That's going to make the function undefined, which is bad. And another bad thing that can happen is you don't want imaginary numbers. But that only happens in even roots. So you want to, it's really what you're doing when you're finding the domain is, what are the bad things that can happen? I'm going to make sure that I disclude any numbers that would make those bad things happen. That's what it comes down to. And then the very last step is, okay, if you didn't see an even root and you didn't see a denominator that has x, then the domain is all real numbers, because that means there's nothing possible that could go wrong. You can put whatever values you want in for x. It's fine. So that's kind of the overall idea. But let's see. Maybe we'll start out with some examples here. First, they want us to find the domain of this cute little guy right here. F of x equals x cubed plus 3x minus 7. Okay. That's a cute little guy, right? Yeah, so find the function. Okay, well, I go through this list here. The first step says, if the function contains an even root, you do something or other. But there's no even root, so I don't have to worry about that. Also, they say, well, if it has a denominator, then you do this other thing. But there's no denominator either. Or no division, either way. So if there's no even root and there's no denominator, then your domain is all real numbers, or the interval notation negative infinity to infinity. So if you know what you're doing, a lot of times domain is easy, but a lot of times it's, I don't know, a lot more thought put into it. Okay, we got another one here, 1 part B. Look at this guy, this cute little guy. I look for, first thing I say, is there an even root, question mark? No, okay. Then I don't need to worry. If there was, then I would worry, okay, but there isn't. How about a denominator with x involved? No, I don't see a denominator either. No fractions, no denominators. Okay, that means if neither of those are going on, then the domain is all real numbers, or negative infinity to infinity. Yeah, this guy right here is just a quick way to write all real numbers, or you could write it in words, all real numbers. So that's it. So number 1 part A and number 1 part B are the same answer. And it's because, I mean, the functions look different, but the main thing is neither of them have any even roots and neither of them have a denominator, so they're all real numbers. But the next guy, though, he doesn't have an even root. There is no square root, there is no fourth root, but there is a denominator, so I have to consult step 2, because that kind of tells you what to do if there's a denominator. It says here, okay, if the function contains a denominator, I have to set that denominator equal to 0, solve for x. Any solutions I get must be excluded from the domain. Okay, so the numerator doesn't matter, and like we said, that's because what we're looking for is just the bad things that can happen, and the only bad thing that can happen to this fraction is if the denominator is 0, because that would mean it's undefined. A numerator being 0 is fine. There's no problem with that. That's why we just ignore the numerator. We just want to make sure this guy is not 0. I'm going to figure out when the heck would that happen. Let me see. If I set this guy equal to 0, if you remember from a previous class, this is where you have to factor to solve this. Let's see. So this should work. I want two numbers that multiply to make x, but add up to, multiply to make 6 and add up to -5. So I think I would need -2 and -3, or vice versa, you know, -3, -2. And then once you factor it, you're going to set each of those factors equal to 0 separately. So I always like to draw a little line to separate them, and then I'll solve each one. If I add 2 to both sides here, I get x equals 2. If I add 3 to both sides here, I get x equals 3. But that means, like it said in the directions, those are the values you want to exclude from your domain. So my domain, I guess if I want to write it down in words, is all real numbers except those guys. So I can put whatever I want into this function except these guys. No, not those ones. Except, yeah, okay. But if you want to be more precise about it, I should write either in set builder notation or interval notation. Set builder would be the set of all x such that x does not equal 3, x does not equal 2, x is a real number. This is just the technical way to write it. Or if you want it in interval notation, I mean, if you're really good, you can probably just write it out right now, but sometimes I have to think about it. Let's see. If I draw a number line, what I want is, okay, everything, so all the way to 2. So wherever 2 is, I want to make sure I don't have that. I'm okay until I get to 3. I don't want that either. and then I'm good from there. So if I want interval notation, it looks like from left to right, I want from negative infinity up till 2, because I don't want to include him, so I put parentheses. But I'd also like, union means I want the next thing I'm going to write also, everything between 2 and 3, not including, but I'd also like everything from 3 on. So it's almost like you have to list those 3 intervals separately, like this very left one, everything up until 2, I have to list that here. Everything between 2 and 3, that's here. Everything from 3 on larger, and that's here. So, you know, pick your poison. You're either going to have to get used to set builder notation, which is the top one, or interval notation. I'd say if you're on the fence right now, I'd probably push you towards interval notation. That's probably more what you're going to use in pre-calc and calc. But if you're more partial to set builder, I think that's fine too. All right, let's move on to the next one. So we have a next one, and if I consult those notes, the first thing I'm supposed to ask myself is there an even root? This is the first time that's the answer to that is yes. There is an even root. So let's see, what does it say we have to do here? Let me consult my steps here. It says, if the function contains an even root, we set the expression inside the root greater than or equal to 0 to solve for x. And this is to prevent imaginary numbers. Because I guess the idea is what I don't want is I do not want to see a negative number inside here. That would be bad. And that would happen when that thing is less than 0. Because less than 0 means negative. I want the opposite of that. So what I want is for this thing inside the root to be greater than or equal to 0. Which means positive. 0 is okay, positive's okay. So I'm going to solve this inequality, you know, move everything over, get x by itself, and this will tell me what x values are good. So I'm going to move the 5 over. Let's see, subtract 5, and we'll have negative 2x greater than or equal to negative 5, okay. And then last step would be to divide by negative 2, but I wanted to throw a negative in there on purpose, because remember, if you ever, in the course of solving an inequality, if you divide or multiply both sides by a negative number, you actually have to flip the inequality, make it go the opposite way. So that's one thing to point out. Flip. This is something from first semester, first year algebra. So if you've forgotten, don't worry, it's been a while. Flip the inequality, and that's because you multiplied or divided by a negative number when you were solving. So this is our answer. This is what we want as our domain. But I want to be careful here. I'm supposed to write it in either set builder or interval. I want the set of all x such that x is a real number. That just makes sure that you don't want any imaginary numbers. I want it to be real, not imaginary, and x should be less than or equal to 5 halves. I don't want anything bigger than that 5 halves because apparently that's what gives me imaginary numbers. That's the algebra I was doing above. But the interval notation would be negative infinity to 5 halves. There we go. That's, yeah, if you were to put that guy on a number line, this guy, less than or equal to 5 halves would be here and on to the left. So yeah, like I said, pick your poison. You're gonna have to either get comfortable with set builder notation, which it's a lot to write, but maybe it's easier to master. And then interval notation, it's quicker to write, but it's harder to master. To me, that's my opinion. But, you know, what are you gonna do? Okay. So blah, 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 blah. Let's see, this last one here, before we move on to the next thing. I want us to find the domain of this guy. Let me see, if I consult my steps, the first thing I was supposed to look for was an even root. And this is an even root because it's a square root. You know, there's a little invisible 2 as the index there, so it should be like square root of blah, 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 you know? So since there's an even root, I'm supposed to take what's inside the root, okay, this guy, and set it greater than or equal to 0, and solve that. All right, I think we've done that. It looks similar to the last one, so I'm going to go ahead and do that. Subtract 24. Got it. Okay, that's fine. And now I'm dividing both sides by negative 3. So I better do like we did in the previous one. I'm going to flip the inequality. Now it goes the other way. And it just so happens that 24 divided by 3 is 8. So I want to make sure that's going on. But then I also notice this is the first one we've seen where there's a problem. There's 2 different types of problems. First, I have an even root, which I already took care of here, so check. But also there's a denominator. So it says, if you have a denominator, you have to take what's in the denominator, this thing, blah, 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 set it equal to 0, and disclude the solution you get from that solution set. So yeah, we've done this thing. Now we have to do this thing. So it's very rare where you see a function where there's not only a fraction, but also an even root. But this is just like worst case scenario, you see it. Well, then now you know what to do. So we're going to set that equal to 0 and try to solve for x. Well, first of all, there's a square root in the way, and I'm going to get rid of it by doing the opposite and squaring both sides. If you square a square root, the square and the square root cancel each other. You're just left with what was inside. If I square 0, I just get 0. And now I'll try to solve it the same way, and this looks very familiar. I'm going to move 24 over, blah, blah, blah. Okay, negative 3x equals 24. And if I divide by negative 3, I get 8. Remember, this is the one you don't want x to be. That's what step 2 says. That you're setting the denominator equal to 0, and you're making sure that that is not in your answer. So I kind of have to combine these two restrictions in my domain. So I want to make sure both of these are happening. So I might think about it for a second. I need x to be less than or equal to 8, but at the same time I need x not to equal 8. So I mean, if you think about it, if I put those together, that means I need, alright, so I need x to be basically strictly less than 8. Because this says x can be less than 8 or equal to 8, but here I said, no, never mind, x cannot equal 8. So it pretty much comes down to x has to be less than 8. So interval notation would be the set of all x such that x is a real number and x is less than 8. But if I want interval notation, I'm going to write negative infinity to 8. So it's, like I said, it's up to you which one of those you want. You kind of pick your poison. You want this guy, that's a good answer, but it takes a while to write. Or this guy, it's simpler, but it's kind of harder to master. Okay. So the next topic, this objective 2, is how to combine functions by either adding, subtracting, multiplying, or dividing them. But this one I think you're going to like a lot. It's super simple. So the idea here is we're taking two functions. So here's f of x, x minus 5. That's a cute little guy. We'll try to color code to try to prevent confusion. And then g of x is x squared minus 1. The first thing they want us to do is find out what f plus g of x is, which it looks complicated, but all you're really doing is, I can rewrite it as, that means I want to take f of x, and I want to add g of x. That's it. So it's very simple. I'm going to write f of x, I'm going to put a plus sign, and then I'm going to write g of x and put a plus sign. F of x is x minus 5 plus, okay, what's g of x? G of x is x squared minus 1. And I think in this particular one, I don't necessarily need the parentheses, but I think for the coming ones I will. So when you're adding two functions, you don't really need the parentheses, but it's probably a good idea. So let me see, if I think about the like terms here, x squared does not have a like term, this guy, neither does this x, but the 5 and the negative 1, they can get together and make negative 6. So that'll be my answer. So that's literally all you're doing. This looks more complicated than it is when you add two functions or subtract or whatever. Alright, now the next thing I want to do is subtract them. So like we said, I'm going to write f of x, but now we're just going to put a subtraction sign and then g of x. So imagine we did the exact same thing we did just now above, but we put a minus sign. This is where it's probably a good idea to put them in parentheses, because now I'm going to have to take that subtraction sign and distribute it into g of x here. So I'm going to write that out real quick so I don't mess up. I'm kind of scared. If I were to distribute the subtraction sign, it's not going to affect the x minus 5, but it'll make the x squared negative, but it'll make the 1 positive because it's subtracting a negative. Alright, now I can go ahead and combine like terms. The negative x squared does not have a like term, neither does the x, but the negative 5 and the 1 get together to make negative 4. So a little different than the previous one. It was a negative 6 because the 1 was still negative, but now the 1 became positive. Alright, and then the next one, now we're multiplying two functions. Even though you don't see a multiplication sign, since you see f next to g, that means we're multiplying. So what I'm going to do is we're supposed to take f of x, and now if you want just to, get ready in your mind, you can put a little multiplication sign. We're supposed to multiply that by g of x. So I'm just going to go grab, what was f of x again? It was x minus 5. Okay, multiplied by g of x was x squared minus 1. Alright, and we've seen this before, supposedly in algebra class. I'm going to FOIL this out. Let's see, the first times the first is x cubed The outer times the outer is a negative x, or a negative 1x. The inner times the inner is a negative 5x squared. The last times the last is a plus 5. And looking at that, there are no like terms, but I feel like if someone's picky, they might want me to write that in descending order of powers. Highest power to lowest power. So I just in case, I might switch the two middle, the outer and the inner terms. Now that looks more like it. Okay. Okay, and the last part of this one, this is kind of more obvious of what to do. F of x over g of x. So I'm just taking f of x, which was x minus 5, making a fraction out of it, and putting g of x in the denominator. Alright, and then this one, there's actually not much we can do, because it's not like I can really divide these, The best thing I can do is try to reduce it. And I can tell by looking at it, it's not going to reduce, but it's just good practice for when it does. So what you're going to want to do is factor anything you can. The numerator doesn't factor, it's just x minus 5. But the denominator, that's the difference of squares, so I'm going to write it as x minus 1, x plus 1. If any of these factors were the same, for example, let's see, like at the top is x minus 5. If this happened to be a 5 right here, that would be another x minus 5, and they would cancel. So those would cancel, and I'd only be left with the x plus 1 in the denominator. But in this case, nothing canceled, so I'm just going to leave it as is. Alright, let's try the next one here. This one's kind of cute looking. So now I think we kind of have the hang of it. I think we can go a little faster. This is f of x, and I know he's going to be involved in all 4 of these parts. So I'm just going to write him 4 times, so that way I don't forget what he looks like. Just, the first part I'll have a addition sign next to him. I might as well do that, huh? That guy plus something. This one's that guy minus something. The third is that thing multiplied by something times something. And then the last one is that guy f of x is over another function. Okay. And that other function is g of x. Let me see here. G of x is this guy, x plus 1. Okay. So x plus 1 is what's being added to f of x in the first part, it's what's being subtracted from f of x in the second part, and it's what's being multiplied by f of x in the third part, and it's the denominator of f of x in the last part. And then we'll see if we can clean these up a little bit here. The first one, the plus sign, is not going to change anything, so I'm just going to go ahead and try to combine like terms right now in my head. The x squared doesn't have a like term. This negative x and this x get together and cancel each other, so they're just gone. This negative 3 and this 1 add up to negative 2. So that looks good there. But then here, since there's a subtraction sign, I want to be a little careful and distribute it, just so I don't mess up. Let's see, that makes the x negative and the 1 negative. Alright. Still, the x squared does not have a like term, but now notice that the negative x and the negative x don't cancel, they actually add up to negative 2x. Alright, and then we have a negative 3 and a negative 1. Those together can make negative 4. That looks good. Ugh, and now we're multiplying. Usually I think multiplying to me is not super difficult, it's just more tedious, and I can make a lot of mistakes because it's so tedious. So okay, I'm going to go ahead, take the 2x squared and multiply it by both of these guys. That'll make 2x cubed plus 2x squared. Okay, now I'll take the negative x and multiply him by both of these guys. That'll make minus x squared minus x. Okay, and then the very last guy, negative 3 times each of these, would make minus 3x minus 3. Alright, let's see. The x cubed term does not have a like term, so he'll just be by himself. These two guys are like terms. They'll make a positive x squared, a positive 1x squared. These two together make negative 4x. And then the last guy just doesn't have a like term, so he's all by himself. And that looks pretty good. Alright, and then the last one, like we said, when you divide two functions or make a fraction out of them, there's not really much you can do. All you can do is try to reduce it. So let's see, this, how does the numerator factor? Let me think here. X and x, okay, there's a 3 here and a 1 here, let me see. A negative and a positive, is that right? Yeah, okay. Alright, ooh, and this is a good thing that I did that, because notice the numerator has a factor of x plus 1, so does the denominator, so they cancel. And you're just left with the 2x minus 3 that was in the numerator, so that's your answer. So you want to be careful. The division is usually the easiest one, because a lot of times it doesn't reduce, but the times it does, you will get marked down by the homework or quiz or whatever if you don't reduce it. Alright. So the next topic is the composition of two functions, which this one's probably the hardest to wrap my mind around, you know? Well, it has what I would say is it has a steep learning curve. If you've never seen it before, it might take you a while to really grasp it. At first you're going to say, what the hell is going on? Well, that's what I was feeling anyway. But then just doing your homework, you're practicing, it doesn't make sense, kind of, you're doing your best. But all of a sudden there'll be a point where it makes sense and you'll say, oh, I get it now. And you'll never forget it. For some reason, this is one of those weird topics where, yeah, it's difficult, but then at a certain point you just get it and you'll never forget it. It's just really weird. So, okay, just the idea is the composition of two functions. Okay, to find a composite function, replace the x in the outer function with the entirety of the inner function, which is crazy. So, for example, this is how they're going to write it, f of g of x. That's how you write the composition of two functions. So it doesn't say that here, but composite functions, it looks like that, f of g of x, or more affectionately known as fog of x. You could think of it as f with, so notice the notation, if you rewrite it like this, it kind of helps. So it's f of g of x, that's how they're going to give it to you, but if you rewrite it like this, it helps. So notice, it's like f of x is like an outer function and g of x is an inner function. But what you're going to do, like it says, is you're going to replace the x in the outer function, which is f. So okay, we're taking f, where the x was, you're going to put g of x. So now it looks like this. It's kind of crazy. Let me see, I'm going to erase this guy. There we go, yeah, so that way the red matches the red. Ugh, so it's weird, but it takes some getting used to for sure. So okay, let's try it, just to get the hang of it. And feel free, if you feel like you have to, don't feel bad. If you have to just keep doing these over and over, try them over and over, then there's no shame in that because they're weird. Or you keep watching this part of the video over and over. It's so weird. So okay, they're giving us two functions. Here's f of x. Maybe I'll color code them again. And then g of x can be red. I don't know. Sure. G of x. All right. And they want us to figure out what f of g of x is. Okay. So like it says in the highlighted area, I'm going to rewrite that as f with g of x inside of it. So what I'm going to do is replace, like it says above, replace the x in f of x with g of x. So kind of, if it's their first time, it really helps me to first do that. Say, okay, f of, and then think about what is g of x. Okay, let me see. G of x, they gave me that function, it's this guy right here. 2x squared minus x minus 1. So I'm just going to go ahead and replace that guy. Okay, just so I kind of know what's going where, sort of. Okay. But f of x itself is 5x plus 6. And like it says, where the x was in f, you're going to write the x squared minus x minus 1, g of x. Ugh. So it's kind of weird, and that's what it ends up being. I guess, you know, we can clean that up a little bit, but that's the idea. Let me see. So I've kind of got too much going on here. I'm going to erase it a little bit. All right, So imagine, I'm taking the x in f of x and replacing it with all of g of x. So kind of just picture that for a second, just what we're up here. Imagine this x right here disappears, it's gone, and this stuff replaces it. So it would look like the 5 something plus 6, you know what this looks like, 5 times something plus 6, but that something is this stuff. And that's exactly what we have going on here. That function, f of x, it used to look like 5x plus 6, but I replaced x with this crap right here. So that's kind of what this looks like. And then, yeah, I think, you know, that's a nice answer, I guess, but they might want you to distribute and simplify. So I might distribute that 5. It's 5 times 2x squared, that's 10x squared, and then minus 5x minus 5. Like I said, just distributing, just to try to simplify. And then the plus 6, and those can get together, those last two terms, those are like terms, to make a 1. There we go, that simplifies it. Ugh. Okay. So now we have the opposite. Now they're wanting what g of f of g of f of x is. But it's always the one on the left is the outer function. Left is the outer, and the right one is inner. That's the hard part to remember. It's not obvious the way they've written it here. Right is the inner, function. So it should be g with f of x inside of it. So maybe that would help. Let me see. What was g of x? G of x was that guy. He looked like 2x squared minus x minus 1. I think that's what he looked like. Is that right? G, where is he? There he is. Yeah, this guy. So it's 2x squared minus x minus 1. So this is pretty much like this. I always think of it as like the skeleton of g. G of x looks like that, but where the x was, I'm going to replace it with f of x. Okay. Because it was 2x squared, but now I want to put an f of x there instead of the x. And then minus x, but I'm going to put an f of x there, minus 1. And then the last step would be to actually replace the f of x with what it was supposed to be. So in the beginning, they told us f of x was, and I already forgot, what was it? 5x plus 6. That was the original guy. 5x plus 6. It happens to show up twice here, but that's okay. There we go. All right, so this is your answer right here. So I guess you can kind of picture what happened here. Imagine, all right, let me, again, I kind of put a lot of crap here to erase a little bit. So okay, what I did, now it was the opposite. I'm replacing the x in this guy with the entirety of the other one. Let's see. So I guess imagine this x and this x disappearing, and this goes in their spot, in their place. And I think it would look a lot like this, right? That kind of makes sense. It was 2 times something squared minus something minus 1. So that's it. And, you know, that's a fine answer, but I think I have a feeling in the homework, like if you type this in your homework, they might say, oh, although this answer is correct, it's not simplified. I think what's happening is they want you to multiply this out. Since this 5x plus 6 is being squared, I'm going to write it twice and FOIL it out. Let's see, and then multiply by 2. That's 25x squared plus 30x plus 30x plus 36. And then I guess I'm distributing this minus sign. It'll be a minus 5x minus 6. And then this minus 1 here that's just kind of hanging out. So that's minus 5x, and then I guess I can combine these right now if I want. That's minus 7. Alright, and then I have to have some like terms inside these parentheses. The 30x and the 30x can make 60x. And then plus the 36. Alright, and then I'm almost done. I just have to distribute the 2, and then I'll combine like terms. If I distribute the 2, I get 50x squared plus 120x plus 72 minus 5x minus 7. Alright, now the 50x squared does not have a like term, but the 120x and the 5x get together to make 115x. And then the 72 minus 7 makes 65. There we go. So that's probably what they would want, just because it's the most simple thing you can get. But the one I highlighted is, you know, it's the correct answer, it's just not quite simplified. So that's probably more what they would want. Okay, and then the next thing they asked for is f of g of negative 1. And that sounds complicated, like, oh crap. They already asked me for f of g of x, remember? Oh, oopsies. F of g of x. Now they want f of g of negative 1. What the hell? Well, all I have to do, I've done the hard part. I found f of g of x above. Where was that guy? It was this thing, right? This guy. So I'm going to bring that back down. 10x squared minus 5x plus 1. Let me see. 10x squared minus 5x plus 1. Is that right? I don't know why I'm feeling like that's wrong. Oh, okay. I guess that's it. But since I already found the function, that was the hard part. Now all I have to do is replace the x with negative 1. So it seems like it's harder than it is at this point, but we did the hard part. X with negative 1, or whatever number happened to be here. That's what you would replace it with. So what I want is 10 times negative 1 squared minus 5 times negative 1 plus 1. So what'll that be? That's, well, negative 1 squared is positive 1. And then negative 5 times negative 1 is positive 5. So pretty much we have 10 times 1, which is 10, plus 5 plus 1, that's 16. So that's the answer there. Alright, so notice the first two parts, we got a function as an answer, and that's because what they asked for had an x in it. They had no numbers. So I shouldn't expect a number as an answer because they didn't even give me a number. Same thing with this guy. They said, what's g of f of x? And my answer was a function. But here they actually put a number in there. That's why I guess I should have saw from a mile away that the answer was going to be a number, not a function. And the last thing would be, what's the domain of f of g of x? But that, we can go back to the beginning. Remember the very first objective or the very first example we did was find the domain of blah, 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 blah. And it said first thing you want to do is look for an even root. Okay, f of g of x actually I found right here. I mean, I found it above, but I wrote it right here. There's no even root, so I want to make a note of that. You don't have to write that down if you don't want, but this is what's going on in my head. No even root. And I look at it also, and there's no denominator. No denominator. So the domain is all real numbers. That's what we decided in the beginning of this section. Domain, all real numbers, or if you want to write it in interval notation, negative infinity to infinity. Whew. So this stuff is tough. It's like I said, it don't feel bad if that didn't make perfect sense, or it didn't even make half the sense it should have. I think the more you see these, the better they get. It's just really weird to get used to. But let's try this next one. Let's see. They're giving us new functions now. F of x is this 4 over x plus 2. And then we have g of x is this 1 over x. The first thing they want is f of g of x. And that means, remember, the best thing to do, I think, is rewrite it. It's the left guy with the right guy inside of it. That helps me. And then I think for some reason colors always help me. Like remembering which one's outside. The yellow one's outside. So the one above that's yellow is outside. The one above that's blue is inside. So let's see. I'm going to write what the outer function looked like. The outer function was f is 4 over x plus 2. That's f of x. It's like the skeleton of f of something. I'm not going to write x yet because I don't really want f of x. I want f of g of x. So where the x was in, hopefully this helps, but this is me replace the x in f of x with g of x. So just picture this yellow function here. It's 4 over x plus 2. What if I took that x, threw it away, and I put a g of x there instead? Hello. And then I didn't even do that. There it is. So I think that's what it looks like we've written now. So that's kind of your first step, and now I'll actually write g of x out. What is g of x? Out as, what is it? 1 over x. That's my last step, and then I should be done, other than maybe simplifying or something like that, but the hard part, the new part, is over. So it's 4 over g of x plus 2, but g of x was actually the function, 1 over x. There we go. So that's my answer, but again, I think this is something we can simplify. And stuff like this is why you learned how to simplify this stuff in a previous class. So, I mean, supposedly. You're supposed to have learned that. But I can simplify this by putting this 2 over 1 and finding a common denominator between these guys. Let's see, and then I'll see what to do. This is 4 over 1 over x plus, if I multiply this guy by x over x, then the two little fractions will have the same denominator, x. And then I can combine them into one fraction, let's see. 1 plus 2x, their numerators together all over that common denominator. And then the idea was, you can think of the big fraction bar, it's 4 fraction bar over blah. Think of it as a division sign, so I'll write it now as 4 divided by 1 plus 2x over x. But if I'm dividing by a fraction, that actually means I have to flip and multiply, so I'm going to say that's 4 times the reciprocal of that, x over 1 plus 2x. And if I put that 4 over 1, I can multiply across. That's 4x over 1 plus 2x. There it is. So I think a big part of the pain and the tediousness of these problems is more like stuff that you've seen before, stuff that should be reviewed. The new stuff is more like, I don't know, you're doing mental gymnastics, just trying to figure out what the hell's going on. Ugh. But let's see, now they want g of f of x. That means g is the outer guy, and f of x is the inner guy. So I want to write g. What does g look like? G is 1 over x, same function. 1 over x, but where the x was, like we said, I'm going to replace x with f of x. Okay. It was 1 over x, now it's 1 over f of x. So what I did was replace the x in g of x with f of x. So I've done that, and then the last step is I want to write f of x out as the function that they gave me. Right? F of x out. Okay, and then I should be done other than simplifying, I guess. F of x was, I already forgot. What was he? 4 over x plus 2. Okay, 4 over x plus 2. That's f of x, but I'm going to keep all the parts of g of x. 1 over blah. Alright. So now this one, there's no separate fractions or no separate terms that need to be combined like in the previous part we just did. When I found f of g of x, I actually had to go and combine two little fractions together. But now I think there's only a 1 over 1 fraction. Now I can just jump to the division part. Let's see, this is 1 divided by the denominator, 4 over x plus 2. But if I divide dividing by fraction, that means I'm multiplying by its reciprocal, which is x plus 2 over 4. And if I put that 1 over 1, I can multiply across and get x plus 2 over 4. There we go. That looks good, huh? Ugh, a lot of work. Alright, and then this next part, this is one, this part looks scary like we said before, but it's not bad. I just remember that the very beginning of this problem, I found what f of g of x was. What was he? Let me see. I'll try to color code it because there's a lot of crap going on here. Where was that guy? F of g of x. When I did all my simplifying and everything, he ended up being here. It's okay. I'm going to bring him down. It was 4x over 1 plus 2x. Let me see here. 4x over 1 plus 2x. Alright. So that's the guy. But now all they want me to do is replace the x there with 2. Replace x with 2. Or, if this was a different number, I'd replace it with that guy. So it should be that exact thing. There we go. That's 4. Let's see. So I want f of g of 2. It should be this exact thing. 4. But I'm going to leave the x blank. 1 plus 2 times blank. But the blank, I want to put a 2 there. Because that's the value they're looking for. So a 2 goes here, 2 goes here. And then I'm just simplifying. The numerator is 4 times 2, which is 8. The denominator is 1 plus 2 times 2. Well, 2 times 2 is 4, plus 1 is 5. There we go. And there's no way to simplify that. That's fine. Let's see. The domain of g of f. Okay, I already forgot what that guy was. G of f was... Where'd he go? I found that. And the second part... Here he is. X plus 2 over 4. Okay. I want to find that here. X plus 2 over 4. There he is. Alright, the domain. So first, when we go back to the very beginning of this section, it said, when you want to find the domain, the first thing you do is you look for an even root. Do I see an even root? No even root. 2, and then this one's almost like a trick. So it said, look for a denominator. Well, I guess let me actually try to do this, and then I'll see why it's not going to work. The denominator, what I'm supposed to do is set it equal to 0 and solve for x. Set denominator equal to 0 and solve for x, but there is no x. So since there's no x, there's nothing to solve. So really the step 2, it should say, not just, if there's a denominator, then you do this. If the denominator does not contain x, there's no reason to do anything. Doesn't contain x, so we're good there too. And it sounds weird, but if you go back to the reasoning behind why do we set the denominator equal to 0, it's because we want to make sure that the denominator never equals 0. So we're trying to find out when it would. But look at that denominator, it's 4. That will never be 0, so I don't have to worry about it. So the domain is all real numbers. I can put whatever I wanted into this. I'll never get imaginary numbers because there's no root. And I'll never get a denominator of 0, which would mean undefined because there's no x in the denominator to make it 0. So the domain would be all real numbers, or, the interval notation version of it, negative infinity to infinity. Oh, man. These sections are tough. I'll tell you that. So if you're having a little bit of a hard time, don't worry. You're normal. It just takes a lot of practice. So I'd practice these on my own if I were you. And definitely write things down. Don't just try to do the homework without writing anything down. Just type your answer. It really helps to write it down, and then it helps too to look back later on at your homework and try to figure it out. But okay, finally we're on the last type of problem here. The last objective is they're kind of, I think the directions aren't really clear. It's not even clear what they want. They said express this function here, h of x equals square root of x squared plus 5 as the composition of two functions. So this type of problem, the idea is they're saying someone, it's almost like someone did one of the above problems for you. For example, they said, hey, find f of g of x, written this way or this way. And let's say they did it, you didn't see what they did, they did it in secret, and they got this thing. Now they want you to go backwards, so go backwards. What they want is, what is the inner function, what is the outer function? What is g of x, which is the inner function? What is f of x, the outer function? So it's really all they're asking for. Yeah, like I said, they're saying, all right, someone composed two functions together. They found the composition, and this is what they got. Now you have to almost decompose it, figure out what it used to be. So when I look at this guy, to me, I think the inner function is what's inside the root, maybe. So I'd say g of x is probably x squared plus 5. That seems like it's the inner thing. F of x is the outer thing, the square root, I would say. But the square root has to have something in it. It has to be an x. That's the weird part. It feels like you don't put anything in it, but it should be an x. And, if you feel weird about that, you think, that can't be right. You can always check. If you take those two functions you wrote, the g of x equals x squared plus 5, and the f of x equals square root of x, figure out what is g of f of x. Well, let me see. If I do what I did before, I'd be replacing the x in f of x. Wait, did I get that? Oh, I screwed it up. I wrote those backwards, sorry. F of g of x, sorry. There we go. I'd be replacing the x here with this entire function, which is exactly what I need. It's the square root of, okay, move the x out of the way and write this stuff, x squared plus 5. That's exactly what was the function that we started with, so I knew I did it right. Plus 5, yep, check. That's the guy we wanted, because that's the guy they gave us. All right, so the answer is these two guys put together. G of x is this, f of x is this. They want to know what's g, what's f. Someone put those things together and got h. So, okay, same thing here. Let me see. So supposedly, f of g of x is this function that they wrote here. Blah. Okay. So they're saying, what is the inner function g? Blah. Okay, and what's the outer function? F of x. Alright, well, looking at this guy, let me see. To me, it looks like what's inside is maybe the, where is it? What's inside the parentheses, I would say. So I'd probably write that. To me, the inner function is the 3x minus 1. Let's see here. So g of x is 3x minus 1. And then I think the outer function is the fourth power, so I'd probably write that. Fourth power. But again, it has to be on something, and that something is always going to be x. So it's going to be x to the fourth power is your outer function. Yeah, and I don't know why I put parentheses. It should just be x to the fourth. Okay, so that's my answer. Just g of x is 3x minus 1. F of x is x to the fourth. And like I said, if you don't feel comfortable with that, you can always check by composing those guys. Do what we did in the previous objective or previous example. If I find out what f of g of x is, that would mean that this thing is going to go inside here, replace x with 3x minus 1, and I think it would look like what we want it to look like. Oh man. Like I said, these are two tough sections, so thanks for listening, and I promise we're almost done with this whole chapter. We'll move on to more interesting things, actually a little simpler. I think this class starts out with the hardest stuff, and then it kind of gradually gets to something kind of interesting and less challenging. If that makes you feel better, I hope. All right, thanks. I'll see you soon.